Welcome back, learners. In the previous part, we had discussed about the metallurgy. What are the metallurgy? And we had discussed here metallurgy is a process of extraction of metals. Along with the metallurgical terms, we had discussed about the different steps which we will use during the process of extractions of metals. So, we had discussed number first step, it was the exploration. We need to explore a good quantity of ore or good quality of ore or minerals which contain high amount of metals in them. And the second step was grinding of ores, and third step was the concentration of ores. And we have seen here the concentration of ores can take place by different physical method, and along with that a physical method. The physical method is froth floatation method, chemical. The another is gravity separation methods. Similarly, hydraulic washing. So these are the physical method, and along with the physical method, we had also seen there fourth type of methods which we will use during the process of extraction is a leaching. Leaching is a chemical separation methods, and after that the next step is a reduction, and reduction is after the reduction we will in the metallurgy the refining and purification of that metals which we will get after the process of reductions. So, and we had discussed there the reduction can take place by different methods. Reduction can be takes place by carbon, can be carbon monoxide, can be heating alone, or can be aluminum, that is aluminothermite process. So, refining of metal or purification of metals can be takes place by different processes, that is distillation, liquefaction, oxidation and electrorefining. So, by these methods we get a pure metal, and after that the pure metal is distributed according to their requirement. So, these all the process collectively called metallurgy. So, metallurgy is a science in which we can extract the metal in their pure form and modifying them for using. Now, first step, crushing and grinding of ore. So, in this step we have to find a good quality of ore. So, the crushing and grinding of ores takes place through the compression of ores against the rigid surface or reduction of size of ores. So, they can be further processed. So, we have to reduce the size of ores by the further processing, and the grinding and crushing takes place through mechanical forces, and that breaks the ore and change the size and shape of ores. So, the grinding can take place with the help of crushers, or the grinders change into small pieces and reduce them into fine powders. So, this process is also called pulverization. So, grinding and reduction of ores into fine powder is also called pulverization. So, pulverization is a process in which we convert the ore into their powdered state. So, this is you can on your screen you can see the ores, and ores can be present in the earth crust with the rocks in the sedimentary layers. So, we have to find that ores, and the compression of ore against rigid surface which reduce the size of ores, and the crushing or grinding of in your screen you can see it is a copper ore, and through the mechanical process the ores undergoes into the concentration process. So, basically grinding of ores is a pulverization in which we have to change the size of ores. By doing that we can use that ores into the further process or comes into the further steps. Now, a second step is a concentration of ores. Now, what is the concentration of ores? It is a process of eliminating of impurities. The impurities present in the ore with can be rock, slit or grit. So, here concentration of ores, during the concentration of ores we can eliminate the impurities. So, the separation of ores from the gangue, also called ore dressing or pre-treatment. So, the concentration of ores is also called dressing or pre-treatment. So, there are different ways. First is hydraulic washing or gravity separation. It is a physical process. So, on your screen you can see there is a block which is called hydraulic classifier. The structure you are looking on your screen is a hydraulic classifier. So, here in this process the principle is it is based on the difference in the gravity of ores. The gravity of ores, on the basis of gravity of ores, here the gravity separation takes place and ore particles eliminate or remove during the process. So, the crushed ore is washed with the jet of water, denser are particles settle in the bottom and the lighter particle, the lighter impurities, that is called gangue, which is washed away. And the types of ores we use during the hydraulic washing, that is oxide and carbonate ores, that is hematite Fe2O3, and tin ores, that is cassiterite SnO2. Another important method which is used for the concentration of ore, that is a magnetic separation. So, here magnetic separation is based on the magnetic and non-magnetic properties of ores. So, here we will find out the ores which are having magnetic and non-magnetic properties. So, the ore, important ore, wolframite, that is the ore of tungsten, and cassiterite, that is ore of tin. So, these are the some ores which are having magnetic properties, and here we have to use the that ores on the basis of magnetic process. What happened in this process? We have to use a magnetic separator, as in the previous you can see here there is a magnetic separators, and you can see on your screen there is a two wheels. So, and on the one wheel are having a magnetic properties, and there is a belt which is moving on the wheel. When we ore powder is putting down from the upon the upper side of that magnetic wheel, along with the belt, that ores runs through the belt which is running on two wheel, is the ore which is having a magnetic properties come close to the magnetic field, while the ore, or we can say the impurities, come far down below, just away from the magnetic that magnetic wheels. So, here magnetic separators consist of a moving belt. That belt moves on two wheels, one of which wheel is having strong magnet. The gangue falls down away from the rollers, while ore which are having a magnetic property stick to the belt and falls nearer to the wheel. And ore collectors collects in one heap. The ore collects in one heap and gangue in another heap. And the types of ores, as I have discussed, wolframite ores, tungsten or cassiterite ore, tin or magnetite ore, pyrolusite ores, chromite ores. So, all these ores having magnetic properties. So, it is a magnetic separation. Next, froth flotation methods. What is the froth flotation methods? It is based on the, here again this is a concentration of ores. So, concentration of ores based on hydrophobic, that is oil wetted valuable minerals from the hydrophilic, that is water, and waste gangue. So, here hydrophobic and hydrophilic. Hydrophobic, we use the water wetted minerals or ores, and one is hydrophilic. The hydrophilic is a water. So, we have to use the froth flotation process for that. So, this is a technique largely used for the concentration of sulphide ores. So, especially we have to use the sulphide ores for froth flotation methods. Example, galena, PBS. PBS is a sulfide ore of that lead. Zinc blende, cinnabar. Zinc blende is a zinc ore, cinnabar is a mercury ore. So, here you can see on your screen the structure, and here minerals particles are wetted by oils and gangue particles of ores are wetted by waters. So, we have to hydrophilic nature of water and hydrophobic nature of oils. So, by these two things we can used in the process of froth flotation methods. So, here one is the collector, another is we used frothing reagents. Frothing reagents or agents which make the froth, that is the froth stabilizers, are added to the ore. So, we have to use a frothing reagents or frothing agents in the ore. So, which make a froth with the water. So, finally divided ore is introduced in the tank of water which containing 1% of pine oil or eucalyptus oil. So, eucalyptus oil or pine oil is act as a hydrophobic. So, they make a froth with the ore, concentrate ores. So, here leaching, it is a very important method. Leaching is a chemical separation. So, you can see the different types of ores on your screen. Now, this is again on your screen, you are looking here ores, crushed ores. Now, what is a leaching? It is a very important chemical methods. So, by chemical separation, we can concentrate the ore. It is also called wet process or hydrometallurgical process, and this method or leaching is applied when the metal is more soluble than impurities present in its ores. So, it is a very principle of using the leaching when the metal is more soluble than impurities which is present in the ore, we use leaching. So, leaching is a chemical separation or it is a wet process. Now, these are the different steps which we will use during the process of leaching. So, ore which containing metal and impurities, right. So, and we have to in the leaching process, I am discussing here leaching process. One step is ore which contain metal and impurities. We used a leaching reagents or leaching agents. So, that is a solution of suitable reagents. So, we have to mix that leaching reagent into the ore, concentrated ores, into the ore which we wanted to concentrate. Now, third step will be metal which is present into the ore converted into soluble salts or complex compounds. The next step will be the impurities remain undissolved in the reagents, and that impurities can be removed by filtration process. Now, the metal can be separated or extracted from the soluble complex salt is called tailing. So, tailing, what is the tailing? Tailing is a concentrated ore which we have to concentrate after the leaching process, and this contain metal. So, the tailing is a concentrated ore which contain metal. So, example bauxite tailing. Bauxite tailing is contain aluminum. It is a ore, but after the concentration process through the leaching, we called it bauxite tailing, and it contains the aluminum metals. There are four types of leaching. Alkali leaching, example bauxite ores, we can undergo the bauxite ore can undergo the alkali leaching. Similarly, acid leaching, example sulfide ore, sulfide ores undergoes the acid leaching. Cyanide leaching, example gold and silver undergoes the cyanide chemical separation method. And fourth one is ammonia leaching. Ammonia leaching is used for the crushed ore of copper, nickel and cobalt. So, these are the different types of leaching we can use depending upon the ore for the concentration process: alkali leaching, acid leaching, cyanide leaching and ammonia leaching. Now what is the leaching process? I will explain you with the example of aluminium. So what is the leaching process? Here I am explaining aluminium. You have to find out the ore. So there are different types of ores of aluminium: alumina, bauxite, cryolite and gibbsite. These are the different types of ore. So what will we have to do here? We have to find out the ore which contain the good and maximum quality of metal. So aluminium metal. So bauxite is a commonly extracted ore. Now we will see the leaching process for this bauxite. Bauxite is a most common aluminium ore. Aluminium can be profitably extracted from this bauxite ore. Bauxite is a rock formed from the laterite soil. So this is a bauxite ore, you can see on your screen, and it is a principal ore of aluminium, and it, in bauxite ore very good quality of aluminium is present inside them. This is bauxite minings. These are the minings. So we have to find out the bauxite minings, and this bauxite contain 40 to 60% high grade of aluminium ion. So it is a bauxite mining, you can see on your screen. Now there are two types of bauxite. It's very important, learners, it's very important points. You have to understand this, as the bauxite ore is a commercially ore from which we can find out, we can extract pure aluminium which is having a very good quality. So bauxite ore can contain two types of impurities, that is FeO and Fe2O3, also silicon SiO2. So two types of impurities can this bauxite ore can contain: iron impurities and silicon impurities. So on the basis of impurities we can divide into two types: red bauxite and white bauxite. Red bauxite, what is a red bauxite? Learners, it is also bauxite ore which contain the aluminium, but it contain the iron impurities. Similarly, white bauxite contains silica impurities, so it's called the white bauxites. What are the process for of the leaching of red bauxite ores? So there are two methods, very important method. One is Bayer's process. So Bayer's process is a very important method, very important leaching method for the extraction of aluminium from the bauxite ore. And there are another method is Hall's process. So there are two process, leaching process. One is Bayer's process, another is Hall's process. Similarly, for extracting aluminium from white bauxite, the method is Serpek's process. Now we will see Bayer's process. What is Bayer's process? As I told you, we are discussing here leaching process. So Bayer's process is used for the extraction of aluminium from the red bauxites. So here in leaching we will use the leaching reagents. So the leaching reagent is here caustic soda or NaOH, and the impurities present in that red bauxite is ferric oxide Fe2O3, which is present in the red bauxite. So here this is red bauxite. When red bauxite is treated with or dissolved with sodium hydroxide NaOH, and here the reaction takes place in a pressure vessels, when red bauxite ore which contain aluminium, also which contain iron as impurities, when treated with NaOH, we get a red mud, that is sodium tetrahydroaluminates 3 complex NaAlOH whole 4. So this is called red mud. So and its name is sodium tetrahydroaluminate. So when this sodium tetrahydroaluminate undergoes cooling, we get a crystallized form of that product. That crystallization takes place in water and we get a aluminium hydroxide. When aluminium hydroxide heated at high temperature, we get alumina. Alumina is Al2O3, and learners, this alumina contain 98% of aluminium. So this is called crude aluminium. So this is the process of leaching, and that alumina, that again the next step is that alumina which contain 98% of aluminium undergoes Hell-Héroult process, and it is a smelting of aluminium. Here a smelting of aluminium takes place, and after that we get a crude aluminium. Crude metal contains almost 90 to 98% of pure metal, pure aluminium metals. So that next process will be purification, and after purification we get a pure metal, and after the step is a distribution. According to the requirement of industries, we can distribute the metals. So these are the different steps we will use during the bare process. Now this is a bare process, you can see on your screen, this is a bare process, and here it is a chemical process, and structure you can see. The last, the alumina which contain at least 90% of the aluminium undergoes Hell-Héroult method. Hell-Héroult is a electrolytic process. So after that electrolytic process we get a pure aluminium. Now these are the steps on your screen involved in the bare process. So as I told you, first is grinding of ores, crushing of ores from the mining, and that ores is treated with any leaching reagent, and as here we used here sodium hydroxide. The reaction takes place in pressure vessels, and after that we get a red mud. Red mud contain iron as an impurity. So it is an sodium tetra aluminum hydroxide. On cooling we get a crystallized form of aluminum hydroxide. So we also call aluminum crystallization sheets. So that aluminum hydroxide, when heated at strong temperature, we get a alumina. So alumina, that alumina which contain around 90% of aluminum undergoes Hell-Héroult process. Now it's a very important, we will find out the reaction, what reaction takes place. So first step, pulverized ore is treated with concentrated solution of NOH. So this is a red bauxite. When we react NOH, we get a NaAlOH whole 4. This is a sodium tetrahydroxyaluminate, and it is a soluble complex, and this process is called dissolution. So it is called dissolution. Dissolution means the ore, the red bauxite which contain aluminium is dissolved with leaching reagent. So this is a dissolution process. So on filtration, iron 3 oxide imparting and gangue remains in the residue. Now the impurity which contain iron, when treated with flux we get a slag. So it is the here reaction FeAl2O3 plus SiO2, we get a FeSiO2 which is a slag. Now what is a flux? Learners, flux is an agent getting attached to the impurities, and why we use the flux? It make a slag. So what is the slag? Slag is the impurity which is removed from the surface. So when impurities react with flux, it moves to the surface of the ore and it make a slag. So slag easily can removed from the surface. Second step is very important step, the complex, that is sodium tetrahydroxyaluminate 3 complex which we have obtained in the dissolution process is passed into carbon dioxide gas through it. So when carbon dioxide gas is passed through this soluble complex, we get a aluminium hydroxide. So the nature of this soluble complex of sodium hydroxyaluminate, it is basic in nature, and carbon dioxide is acidic in nature. So what happen here? Neutralization reaction takes place. So we get a dirty white colored precipitate of aluminum hydroxide, and this process is called neutralization process. So first step is dissolution, second step is neutralization, and in the third step is very important step, because ignition takes place here. So we have to ignite. On ignition, aluminum hydroxides gives alumina. So the on neutralization process we get aluminum hydroxide. That aluminum hydroxide, when heated at high temperature, that is 1400 Kelvin to 15,000 Kelvin, we get a aluminum Al2O3. So this alumina convert into aluminium, and aluminium is a pure form, and it is can be obtained by further reduction, and that is pass into refining process. So by the refining process we get the pure form of that aluminium. So learners, as I discussed, that is the red bauxite, which during the dissolution process we get a red mud. So this is the red mud you can see on your screen. So red mud contain these type of impurities, and globally 3 billion tons of red mud are now stored in massive waste ponds or dried mounds, and it contains toxic heavy metals, and its high alkalinity makes it corrosive in nature and dangerous to the soil by products of Bayer's. So this is the Bayer's process, and the Bayer's process, during the Bayer process we have to release a high quantity of that red mud. So red mud is very dangerous, it is very corrosive in nature, and it destroy the nature of soil also, and it is used to make dry cake, also utilized to extract rare earth elements. So learners, in this lecture we had discussed the various process used for the extraction of metals. Like we had discussed physical methods, and along with the physical method we had discussed the wet process or chemical process, that is leaching method. Thank you.